Today's topic is LibriLight. Can you tell us about the LibriLight project?
Okay, so I'll talk about the project my group's working on with LibriLight. So firstly, I want to explain some other terminology. There's this online project called LibriVox, which is audio recordings of people reading books that are like in the public domain. These books are all old books because copyright lasts an extremely long time. But volunteers have recorded them, and that's its own project. But then, so this guy Vasil Panayotov, and I'm on the paper too, a long time ago created a data set out of that called LibriSpeech. That's about 1,000 hours. And that's been widely used, but these days 1,000 hours is no longer considered very much. So I think it was Facebook that created the LibriLight data set. But LibriLight doesn't have aligned transcripts in the same way that LibriSpeech does. So LibriSpeech has, it has audio segments with sentences, so it's relatively easy to train an ASR system. LibriLight doesn't have that. I think it's intended for use in situations where you don't want to use any supervision. So what we're working on in my group is taking that same set of books in LibriLight and creating something that we're going to call LibriHeavy, which is basically LibriLight but with aligned transcripts. So this text search repository, this is Kangwei's clone of it. He's doing most of the coding actually. This is all about fast alignment of an ASR transcript with a long reference like a book. So the idea is that we make a long kind of time aligned transcript of the entire chapter because it's recorded in chapters, and then we use some fancy algorithms to align that to the corresponding book. Now, if you were to try to do Levenstein alignment, it's an algorithm that it'll take time, like the length of the chapter times the length of the book to do that alignment, and it's too slow. It takes days per chapter or something ridiculous. So in this repository, we have a fast algorithm for doing this. The basic way it works is it uses suffix arrays. A suffix array is a sorted list of all the positions in a text, sorted by kind of reverse lexicographical order of the suffix of the text that ends at that point. So basically what the algorithm does is it creates a suffix array out of both the transcript and the reference text. And it uses the suffix array to find, like, let's call them close matches, places where for each position in the transcript, we get the positions in the reference that are lexicographically like just above and below it. So we call those like close matches or candidate matches, and you can view it if you view it as a matrix of reference position by transcript position, the reference being longer because it's a whole book, then you can view it as like a series of points sprinkled all over this rectangle. And generally speaking, we expect there to be kind of a line going diagonally upwards at some point in that set of sprinkled points. And the way that we find that line is we simply ask, what's the longest sequence of points on this scatter plot that you can get from one to the next by going up and to the right at any angle, but has to be upwards and to the right. And it turns out that there's an efficient algorithm that can solve that problem. it's not even a fancy algorithm. It just uses the std set, which is sorted. It uses certain properties of that data structure in C++. So so we use that to find the alignment, and then we have an algorithm on top of that that finds good segments. You know, it looks for pauses and stuff. Now, a slightly complicated thing here is that the transcript, because we made it with one of our older models, it's just all uppercase with no punctuation. But the reference, we want to keep all of the punctuation on the casing, because we want to train a mixed case system. So part of what this text search repo does is it can do normalization while keeping track of the original text positions from before normalization. So for instance, when we remove punctuation from the reference, we keep track of the original position of each character from before we did that, so that after we get the Levenstein alignment on the normalized text, we can kind of map all of that back to positions in the unnormalized text. So basically what we're doing is we're using the unnormalized text as a reference, as the reference when we train the system. And we don't do any normalization at all. We just basically let the system learn whatever's in the text. And for punctuation and stuff, it'll just pick the most common option at each point, because there's different styles of quotations and things like that. So it'll generally just pick the most common one. I don't know if that's like double quote like there is on a keyboard, or if it's the begin double quote and end double quote. Are we going to show that I sent some text?
Yeah. Can you explain these results?
Yeah. So this is some decoding results with the system that we built on a subset of LibriHeavy. I don't recall how big the subset was. Someone said it was a medium-sized subset, and I think that was defined somewhere by Facebook. But you'll notice that about half of the sentences are transcribed as all uppercase. Hype is our transcript. The reason for that is that in the data loader, half the time we normalize the text to be all caps with no punctuation. So basically, approximately half the time, it's transcribing in that style. It's a bit random. It depends what's at the beginning of the sentence, I think. This is not how it's going to be eventually. Eventually, we want to do some stuff with like a style prompt, a bit like Whisper, so that we can dictate the style that the transcript appears in. But for now, it's just giving a quasi-random thing. But you can see that it does a reasonable job of putting the punctuation. It's not always exactly the same as the reference. You can see that there's an extra comma after Hospital right there, but you know, it's still reasonable. And I think it would have been very difficult to insert this punctuation without access to the audio, because a lot of it it's indicated by how you read it. Yeah. So I'm pretty pleased with what these look like. And also, this is just a subset of the data that we're going to eventually train on. We're preparing other sources of data too.
Okay, and what about this result?
Oh yeah. Okay, so I think this is actually one of the references. I pasted it in a weird way. I think if I recall correctly, this is just one of the references. We don't have to talk about that. When there's weird punctuation like that, generally speaking, the system is not going to ever recognize things like that. because it's, you know, it's too unusual.
Okay.
Yeah.
And is this the same one?
This looks like it's oh yeah, it looks like it's the same one. The reference has slightly more random looking punctuation there because you know, each book is punctuated differently, but in the hype it will generally punctuate it in a more consistent way. So the hype is our recognition after we train the system. Yeah, it looks like that enormous avalanche sentence seems to have been repeated twice because it's twice, appears twice in the ref and twice in the, does it?
Why is
No, there's just one ref and one hype.
why is this capital?
I don't know. I guess it must have, you know, a long time ago, people used to use capitals a lot more freely than we use them now. It's one of these old books, but generally speaking, we don't see that in the hype unless it's all caps.
How easy is it to try this project at home?
Well, I'd like to encourage people to try it because it's going to give us feedback on how easy this recipe is to use. Now, I don't recall exactly how tied in this is with the details of how we transcribed it in K2, but in Icefall. But I think for people who are already using Icefall, it might be doable for them to try this recipe. Yeah, they might have to ask questions. For instance, I don't recall whether our recipe that we got the transcript and spliced the pieces together into one long transcript. I don't recall whether we have that public on Icefall, but people can always create an issue to ask.
And why use this recipe opposed to another one?
Well, I don't believe there's any good solutions out there for aligning like long transcripts with long reference text. There are solutions out there. We have some scripts in Caldi, but I don't think they're as accurate as this because they don't work up with such long segments. Plus, our algorithm is very technically neat. You know, the fact that we can do it so fast, I think that's something unusual. But yeah.
Okay, thank you. That was
Bye.
Kobe.
Bye.
Bye-bye.